Ever heard that expression, happened in a flash? Well, get ready, because today we're diving into something even faster, like way faster.
Like way, way faster.
We're talking attoseconds.
Attoseconds are so short, it's almost impossible to wrap your head around.
Yeah, I mean, how short are we really talking here?
Okay, so imagine a single second. Got it. Now, an attosecond compared to that second is like that same second compared to the entire age of the universe.
Mind-blowing, right?
It's like trying to imagine the smallest thing possible.
That's essentially what we're dealing with, the incredibly tiny timescale of electron movement.
The very things that hold everything together.
Exactly. And our guest today, well, she actually builds the cameras that can capture events happening that fast.
Oh, wow. Yeah, we've got Francesca Calegari, a total rock star in the world of ultra-fast science.
And her work is basically like watching a molecular movie, seeing how reactions occur in real time.
It's like hitting play on the universe's fastest video player.
We're talking about seeing electrons dance, folks. And to think, for the longest time, we could only study matter in snapshots, like looking at still photos.
But her work, boom, it's like someone finally figured out how to hit play.
This deep dive is going to be full of those whoa moments, I can already tell.
We're digging into her interview on the Under the Microscope podcast, so buckle up.
Okay, so I got to ask, how do you even make a camera that fast? Is it like a tiny little device that chases electrons around?
Well, not quite. Think super short light pulses, kind of like a super high-speed flash on a camera.
Oh, so instead of freezing a speeding bullet, we're talking about freezing electrons in action.
Exactly. But instead of a shutter, we're using lasers. And not just any lasers. These things are mind-bogglingly precise.
So how do you even make a laser pulse that short? I can barely even picture an attosecond.
It's some seriously impressive engineering, let me tell you. They start with a regular laser, right? And then they use this technique called high-order harmonic generation. It sounds super complicated.
It kind of does, yeah.
But basically, they take this laser and focus it really, really intensely onto a gas, like a jet of gas.
Okay, so it's like shining a flashlight at a disco ball. The light just gets scattered everywhere.
You got it. That interaction, that scattering, it generates these incredibly short pulses of light that are, get this, even more energetic than the original laser.
Whoa, hold on. So you're saying they're taking regular laser light and somehow making it even more powerful?
Not just more powerful, but they shift it into the extreme ultraviolet or even the soft X-ray part of the spectrum. It's like laser light on steroids.
And that discovery actually won the Nobel Prize in physics recently, didn't it?
Yep, cutting-edge stuff. But generating the pulses is only half the battle. Then you got to figure out how to actually film something with them.
Right, because it's not like you can just point and shoot with an attosecond laser, right? What are they actually looking at?
They use a clever method called pump probe. Imagine the first laser pulse is like the starting pistol in a race. It sets the action in motion.
Okay, so it's like that initial go signal that gets the electrons moving?
Precisely. Now, the second pulse, that's our attosecond flash. It takes a snapshot of where those electrons are a tiny fraction of a second after the starting gun.
So they're basically taking a series of super fast snapshots at different stages of the race.
And just like with those flipbooks you had as a kid, by putting all those snapshots together, they can create a movie of the electrons movement.
That's incredible. But I imagine those pictures aren't your typical photographs. How do you even make sense of that data?
You're telling me.
Yeah.
You need some incredibly sensitive detectors, for one. And then it takes a whole lot of brain power to decipher it all.
So they have like supercomputers crunching numbers and stuff?
You got it. The scientists team up with theoretical physicists who build computer models based on the data. It's like assembling a giant jigsaw puzzle, but instead of a picture, they're revealing the hidden world of electron dynamics.
That's amazing. Now, I've got to ask about Francesca's journey in all of this. It all started with a pretty simple gift, right?
You know it. A microscope given to her by her mom when she was young. Who knew it would spark such a fascination with the invisible world?
Talk about a full circle moment from a childhood microscope to building the world's fastest cameras.
Right. And her path led her to DSY, which is this massive synchrotron facility in Hamburg.
That's where she got her start in research, and now she's a leading scientist there, pushing the boundaries of what we thought was possible.
It's pretty inspiring, to say the least.
But I heard it wasn't always smooth sailing. Didn't she face some skepticism early on?
Oh yeah, definitely. When Francesca first proposed using this attosecond technology to look at complex molecules like amino acids, people weren't exactly on board.
Really? Why not? Was it just too ambitious at the time?
Exactly. They thought it was way too complicated, that getting any meaningful results would be practically impossible.
So what happened? Did she prove them wrong?
Oh, she absolutely did. Francesca managed to overcome those challenges and actually opened up a whole new avenue of research in the process.
That's remarkable. So what's she focused on now? Is she still working with those amino acids?
Well, she's still using those crazy fast lasers, but she's made a bit of a switch. She's moved on to a different kind of light. Instead of those super short, high-energy pulses, she's working with ultraviolet light now.
Ultraviolet. Interesting. So bringing it back down to Earth a bit, but still on that crazy fast time scale.
Exactly. It's all about relevance, you see.
Okay, I'm listening. What's so special about UV light?
Well, UV radiation drives a ton of important reactions, like think about photosynthesis. That's how plants make food.
Right, the basis of life on Earth.
And even how our skin produces vitamin D, it all comes back to UV light.
So by using UV pulses, she can sort of recreate those fundamental processes, but with like a superpowered magnifying glass.
That's a great way to put it. It's giving her team a front row seat to these ultra-fast dynamics that are, well, essential to life as we know it.
That's just wild. I mean, the potential applications here are mind-boggling. But even with all these incredible discoveries, it sounds like Francesca has some thoughts about how the research world itself could be improved. What were some of those wishes she mentioned?
Yeah, she definitely had some strong opinions. One thing she's really passionate about is seeing more open funding for research.
Open funding. What does that mean exactly?
So right now, she feels like there's too much pressure to chase after the hottest topics, whatever's trendy in the field.
Ah, so instead of following their own curiosity, scientists have to focus on what's popular at the moment.
Exactly. And Francesca worries that this kind of pressure to conform might be causing us to miss out on some really groundbreaking discoveries.
Because sometimes those aha moments come from unexpected places, right?
Precisely. The most exciting findings often come from those moments when you're free to explore, to follow your intuition wherever it leads.
So it's kind of like saying, hey, give scientists the freedom and the resources to explore the unknown, even if we don't know exactly what we're looking for yet.
Exactly. That kind of open-mindedness, that trust in the process of discovery, it's crucial for scientific progress. And it's not just about the funding either. Francesca also feels very strongly about diversity in the scientific community.
Yeah, that really came through in the interview. It's obviously something she's very passionate about.
And for good reason. She talked about her own experiences as a woman in a field that's, let's be honest, still very male-dominated. And how even when you achieve incredible things, there's always that nagging question.
That question of, did I really earn this? Or was it just because of my gender?
Exactly. And that feeling, it's not just an individual experience. It points to a much bigger systemic issue within STEM fields.
And it's a shame because when we limit opportunities based on things like gender or background, we all lose out.
Right. Francesca pictures a future where a scientist's gender, their nationality, their background, none of that even crosses your mind.
Because it's just normal. Everyone is welcome, and it's all about the work itself.
Absolutely. A truly inclusive environment. It benefits everyone. More perspectives, more collaboration, more innovation. Everybody wins.
A rising tide lifts all boats.
I like that. But even with all her success, all her ambitions to change the research world, it sounds like Francesca still misses the simple joy of getting her hands dirty in the lab.
Yeah, she admitted as much. When you're at the forefront of a field, you often end up taking on these leadership roles, which come with their own demands.
Oh, for sure. Suddenly you're pulled in a million different directions, even if what you really want is to be in the lab chasing those aha moments.
Exactly. It's something a lot of people can relate to, I think, that feeling of missing the hands-on part of what you love.
Definitely. But hey, it sounds like she's using her platform to advocate for positive change, to make the research world a better place for everyone. That's pretty inspiring in itself.
Absolutely. So to recap, Francesca's work is giving us this incredible glimpse into the mind-bogglingly fast world of electrons, the very building blocks of, well, everything. And she's not just making groundbreaking discoveries. She's challenging us to rethink how we do science, pushing for more freedom, more diversity, more trust in the process of discovery itself.
It's powerful stuff. And it makes you wonder.
It really makes you think, what other mysteries are hidden in those tiny slices of time? Stuff we haven't even begun to imagine.
It's like we've stumbled into a whole new dimension of science, right? We used to think we were limited by the speed of our own senses.
But now we're talking about a timescale where even a blink of an eye feels like an eternity.
Exactly. Think about it. First, we were bound by what we could see with our own eyes. Then came cameras, able to capture things our eyes could never see, like that classic example of a bullet flying through the air.
Frozen in time.
Right. But now, with attosecond science, it's not just about seeing faster. It's like we've hit zoom on reality itself. We're peering into the fundamental processes that make up, well, everything.
It's mind-blowing. But it also begs the question, if we can see it, can we control it? I mean, imagine harnessing the power of electron movement. That could revolutionize so many things.
Now you're talking. Imagine materials with properties we've never seen before, all because we can control their electrons. Or super efficient solar panels that mimic photosynthesis, pulling energy from the sun at incredible speeds.
Or maybe even computers that operate at the speed of electron movement. Talking about a processing speed boost, we're talking about turning science fiction into science fact.
Exactly. And it's all thanks to the passion and dedication of people like Francesca Calegari, pushing the boundaries of what we thought was possible. And the best part is, this is just the beginning.
It's like we've only just scratched the surface.
Every new discovery in this field opens up even more questions, even more avenues to explore. It's incredibly exciting.
It really is. So the next time you find yourself thinking, wow, that was fast, remember, there's a whole universe of activity happening within that tiny fraction of a second. A hidden world just waiting to be discovered.
In Francesca's work, it's a testament to the power of curiosity, the importance of challenging assumptions, and daring to look beyond what we think we know.
Because who knows what incredible breakthroughs are waiting for us when we embrace that sense of wonder and push those boundaries of possibility. Thanks for diving deep with us today. This journey into the future of science has been truly electrifying.